Some 8,000 tonnes of space debris orbits the Earth, ranging from obsolete satellites to tiny flecks of paint. The United States tracks 23,000 objects larger than about 10 centimetres. ESA receives the data on these objects and analyses them for any possible conjunctions with its functioning satellites.
The big ones are the ones that, if they get impacted, will create a cloud of other smaller debris, which in turn could hit other debris, and this could start what is called the Kessler syndrome, a chain reaction which is not controllable. The problem of the space debris has to be fixed in two ways. First one, we need to stop polluting. And second way, we have to remove the garbage, if you want, the debris.
At ESA's ESTEC Centre in the Netherlands, engineers are developing ED-Orbit, designed to capture an out-of-control satellite and remove it from harm's way. It's being tested using a robot and satellite model.
We use the camera, which is mounted on the smaller robot arm, to reproduce the motion of the satellite around the target satellite that we want to deorbit, to capture. Once we are sure we are moving like a single object, we are like, as if we were dancing but without touching each other, we can move the robotic arms to grab the launcher adapter ring. So it makes us easy to bring it down to the Earth and destroy it in the re-entry or in the South Pacific Ocean.
Another approach involves using nets to capture space junk.
So the concept is to, let's say, to mimic what the fishermen do on the sea, and so to have a very large net to stay away from our debris and mad satellites that is tumbling and moving freely, and then from that distance to keep our net, and you just try to wrap all over your satellites.
Although ED-Orbit is still in development, ESA scientists will be closely watching a UK mission remove debris. This will trial the net concept in the coming months, using a test satellite launched from the International Space Station. In the meantime, the priority is to make sure new satellites don't add to the problem. Ideally, at the end of their lives, satellites are either parked in graveyard orbits or their course adjusted to re-enter the atmosphere. This is an ATV supply ship burning apart over a remote area of the Pacific Ocean. But even with planned re-entries like this, tough components in titanium and steel can survive to hit the Earth.
Right now we're trying to understand what happens to the materials we use, and then we'll see how we can improve them, how we can work on the design and conception of the satellite, how the different parts of the satellite break up in relation to each other, in order to have a satellite which is safer at the end of its life and creates the smallest amount of debris on Earth.
ESA supports and follows international guidelines to reduce space debris, but it's up to all countries to work together to combat the problem. With our increasing reliance on space, dealing with debris is in everyone's interest.